start spermatogenesis, that in females, this whole process of oogenesis. Now, what is oogenesis? Oogenesis or spermatogenesis, it starts with the oogonia or spermatogonia, right? And then they divide by mitosis into various primary oocytes. And then after primary oocytes or primary spermatocytes, then the meiosis or meiosis comes into play. That is the whole point. In males, it starts at puberty, pivotal age. But in females, it starts prenatally. That was a difference that we already discussed. Yes. So as last point which we were discussing was that in females there is a specific number of all these oogonias and oocytes. In males, and therefore in females there is around a specific age when you might have heard of a word like menopause, when there are no more oocytes to be ovulated out of the ovary. But in males, normally this andropause age is quite variable because there are millions and millions of sperms which are continuously being produced inside the seminiferous tubules of the testes, right? So there's no specific age over here. Basic differences we should know about this oogenesis and spermatogenesis. Other things, other more interesting things are over here. This is just an image of the sperm over here. Now here, as I was saying, that I hope you can see the images, guys, over here, that as in females, we said that it starts before the birth of the female. Prenatally is what I'm writing over here. So what does it mean? Now here in this image, what you're seeing over here is a developing embryo. Yes or no? You're seeing a developing embryo with a head end over here, a tail end over here. Okay. And this all is a yolk sac. This all is a yolk sac over here. And above you have this amniotic cavity. Right. This is a developing imagine it to be a developing female. What happens over here? In this developing female, or you can supposedly call it a male also, you have the primordial germ cells. You call it as PGCs. We have the primordial germ cells in the wall of the yolk sac. Yolk sac is over here. You can see the yolk sac over here. Now, these are the ones, primordial germ cells, like this. These are the ones which are going to migrate, and then they will reach, suppose it is a female, they will reach the developing ovary. These PGCs are the ones which are going to reach the developing ovary. Okay, and then there's going to be oogonias, and then there's going to be other rapid divisions. But in case of males, the PGCs will reach the testes, but they will remain dormant over here till puberty. That is a basic difference. The second difference over here, as we have tried to show over here, the meiosis 1 and meiosis 2, so we can understand the first meiosis and the second, because meiosis, there are two your divisions of meiosis and mitosis. The meiosis is basically divided into two cycles, meiosis 1 and meiosis 2. Happens in both male and female. The point over here is that in case of oogenesis, female gametogenesis, this meiosis 1, when it occurs, it gets arrested in your which phase? In your diplotin phase. Okay, so let me write over here. Yeah. Case of females, let me write just meiosis 1 because that can come as a good question. You can just highlight it also. It gets arrested. It gets arrested in which phase? Do remember, in diplotin. Which phase? In diplotin. Diplotin stage of prophase 1. If you remember, prophase, anaphase, telophase, and prophase, anaphase, metaphase, telophase, all that. So this meiosis 1 gets arrested in diplotin stage of prophase 1. Prophase 1. Okay, prophase, metaphase, anaphase, telophase, all that. And the meiosis 2, when this will start, then this will again get arrested. Where? It will get arrested in metaphase 2. So please do remember these two basic things that have come a lot in your MCQs, and they are obviously quite important. So second meiosis, it gets arrested in metaphase. And the first meiosis, it gets arrested. Arrested means it gets stuck there for some time. Okay. So first meiosis in diplotin stage of prophase 1. Now, when do they come out of arrest? This is another question. So do remember that this first meiosis, when it gets arrested in diplotin stage of prophase 1, it comes out of the arrest when the female child attains pubertal age. And after that, a specific number of oocytes will come out of the arrest. And what about this metaphase 2 arrest? When does it come out of the arrest? It will come out of the arrest only at the time of fertilization. Only at the time of fertilization. When the sperm tries to enter into the secondary oocyte, only then the meiosis 2 will come out of the metaphase 2 arrest. So do remember, at the age of puberty and at the time of fertilization, they will come out of arrest. They will come out of arrest. Arrest is not some jail over here, but yeah, The cell division actually stops at that particular stage, diploid stage of prophase 1 and metaphase 2. So this point to remember, right? This we already seen that, okay, they are coming out the primordial germ cells, they reach the developing gonad. In males, they remain dormant over here. Okay. Now, as you can see, the mitotic division. So what is actually happening that when the PGCs, they turn into the oogonia, and when the oogonia turn into primary oocyte, it's basically a mitosis. But after that, because it's a gametogenesis, there is meiosis. So I guess we know that what is the basic difference of mitosis and meiosis. So just to revise, meiosis is a reductional division when the 2n reduces to n. Therefore, gametes are haploid. Our somatic cells in the body are diploid. Only the gametes, the germ cells, they are haploid because they come out of the meiosis. Therefore, when the sperm and the oocyte meet, then there is a restoration of diploid number. N plus n becomes 2n. So meiosis is a reductional division, while mitosis, it's a non-reduction. 2n converts into 2n into 2n like that. So that's the basic difference. That's the basic idea. I hope you all must have read that in schools also. But that should keep in mind. Okay, now here's a question that which cell undergoes fertilization? Do you remember when we are discussing this over here, when does the arrest happens? When do they come out of the arrest? Okay, so the meiosis 2, it got arrested in metaphase phase and it came out of arrest at the time of fertilization. Now they're asking us a question, which cell undergoes fertilization? Is it a primary or secondary oocyte? Think about it. We were dealing with the meiosis 2, right? So it will be a secondary oocyte. So first our answer will be either C or D. Then in which arrest? So meiosis 2 was arrested in prophase or metaphase? Sir, it was metaphase 2 arrest. Very good. So answer is option number D over here. The secondary oocyte in metaphase arrest is the one which undergo fertilization. And when the sperm will come, and fertilize with this, only then the meiosis 2 will actually get completed because it will now come out of the arrest. I hope you're getting my point. And this N over here meets with the N of secondary oocyte, and then the zygote 2N is formed. That is the fertilization, and that is what is our beginning of embryology. Now we have started to begin the embryology over here. Okay. After in females, when does an oocyte complete meiosis 2? As we have seen already, when does it complete? Let's look at previous question. Meiosis 2 will get complete when the sperm will come in and fertilize. So it will complete the meiosis 2 after the fertilization. Answer is after the fertilization. Do remember this. Okay, there are some sample MCQ questions which have been asked previously in our competitive exams. Trying to show you. Okay, now we can go with the 3 weeks in a bit of detail. Week 1, week 2, and week 3. Okay, general embryology is about the 3 weeks. So as I told in the beginning that week 1 is what? Week 1, if you recall, then week 1 was from the time of fertilization to when the implantation begins. Yes or no? This is what we have discussed. Now, where does the fertilization occur? That is another question. Fertilization occurring where? Yes, sir, you said fallopian tube. Yes, I perfectly correct. I said fallopian tube. Where in fallopian tube? It normally occurs in the ampulla part of the fallopian tube. So what is ampulla part? There are various parts of fallopian tube. We'll see that. So this is also actually a question. Do keep that in mind. Whatever I'm saying, any line over there, are normally all the questions. So either you can make notes also if you want to. So fertilization occurs in the ampulla part of the fallopian tube. Now, from there, what happens is when the fertilization has occurred, what would be that stage known as two-cell stage, right? So the cell division has already started. So now it will be converted into a 2 to 4 cell stage and 4 to 8 to 16 and all that. Then comes the stage of morula. What is morula? Morula occurs around the third day. Around which day? Around the third day. It is a solid ball of cells. It is regarded as around 16 to 24 cell stage. 16 to 24 cell stage. Now, let me show you an image over here. Here is a good image for you to understand. I guess it is the best image to understand the weak one. Just go through it. This is the site of an ovary. You can see the graphene follicles, all this corpus luteum and the other, this primary, secondary follicles over here. Now here the ovulation occurred. Okay, the ovulation occurred over here, and you can see that in the ampulla part we have this fertilization which occurred over here. Okay, in the ampulla part, this fertilization which occurred over here, you can see in this 12 to 24 hours, what is happening over here? Okay, fertilization and ampulla part. So what are the parts of fallopian tube? Let us start with this. This number one, this part over here will be known as infundibulum. Infundibulum, part number one. This part number two, where all the fertilization is occurring, that is the part number two, ampulla, AMPULLA, because it's a dilated part. Part number three over here, which is slightly constricted, it is known as your isthmus. It is known as isthmus. And the fourth part of fallopian tube, which is entering inside the uterine cavity, that is known as intramural or interstitial part. So fourth part is intramural or interstitial part. Now you might wonder, sir, why, sir, you are telling us the parts of fallopian tube? I'm telling you guys because they have come in the exams. It is my reason to tell you that, okay, at least this is very basic. So normally students miss it out. But you don't miss it out. That first part is infundibulum. Second part where the fertilization occurs is ampulla. Third part is the constricted part, isthmus. And the fourth part is going inside the muscle of the uterus. So myometrium, so we call it as intramural. So don't forget these four parts, just an extra point over here, which I'm trying to tell you. Okay, now here you can see that this zygote has formed over here. And now the cell has started to divide. Cells have started to divide. Now, what happens is around the, which day? Around the third day. There is around the day third. So D3 I'm writing, that is day 3. Solid ball of cell have formed. Don't forget that is known as morula. A very, very, I don't know why it's such a favorite question of all the exams. They'll definitely ask you morula. So remember it is around day 3. And in the new textbooks, they've also divided into an early morula and a late morula, early and late morula. So just say that around day 3, we have early morula, then we have late morula around 3.5 to 4 days. Fine. Now see over here, you can see there's a red color is covering around this developing embryo. This red color which is shown over here is basically what is known as a zona pellucida layer. What is this? You can see it from inside the ovary also, you can see, right? It is a zona pellucida layer. What is the zona pellucida? We'll understand, but just remember what is this? It is a zona pellucida. First, go through all the parts of the first week. So day 3, we have this morula. Then see, this morula has entered the uterine cavity, right? Around 4 days, that is the late morula stage. Now you can see that after few hours or around the 5th day, that red color has disappeared. Yes or no? In this number, you can see the red color has disappeared. So I'm writing ZP bracket minus, zona pellucida minus. So you're missing the zona pellucida. And then around the 6th day, that is the and we are nearing the end of the first week, you can see that it has entered. The zygote is trying to enter inside the uterine wall. So that is your beginning of IMP. What is IMP? IMP is important also, but IMP over here refers to implantation. Implantation has begun. So the specific points, day 3 morula, okay, and then you will see you can see also the difference. Morula is appearing like this. Okay, you can see a lot of cells, and then on the 5th day, let me be specific. Where the zona pellucida is missing, when the zona pellucida is missing, you are seeing the zygote cells are concentrated to one area. Okay, here you can see concentrated one area. And if I make a star mark over here, it is this part of the zygote is empty. It is not empty. It is filled with fluid. Now the cells inside, what are they known as? The cells, or the dividing cells inside, they are known as blast, or they are known as blastomeres. Okay, dividing cells. Okay, blastomeres. Now what happens as soon as this group of blastomeres, now listen very carefully, as soon as this group of blastomeres, which is around 24-48 cell stage, it reaches the uterine wall. Now there are two things which occur. What is that two things? One is that the fluid will enter. The fluid will start to enter. But how can the fluid enter? Only when the zona pellucida starts to disintegrate. Okay, so as around the 5th day, when the zygote has reached the uterine wall, the zona pellucida will start to disintegrate, and then the fluid will enter. When the fluid will enter, this group of the cells we can call it as blastocyst. Cyst means any cavity having fluid, blastocyst. That is also frequent asked question. Which day blastocyst? It is 5th day. Now you might have wondered, why is the zona pellucida? Why zona pellucida First of all, was there in the beginning of around 4 to 5 days, and now why it has disintegrated? The answer to this is very simple, that why there is zona pellucida in the beginning. Zona pellucida was there in the beginning because, first of all, it prevents polyspermy. Because you can see that the thousands and lakhs or even millions of sperms which reach the secondary oocyte. So if all of them start to enter inside, it is going to be there's going to be no progression of the developing embryo, right? So it prevents polyspermy. Only when the one sperm will enter, all the others will obviously be disallowed to enter inside. So it polyspermy is prevented. So isn't that very important? You'll say, okay, sir, that is fine, but that is effective till only 1 or 2 days. Why the ZP, zona pellucida, is there till the zygote is reached the uterine wall? Why? Because second thing, it also prevents ectopic implantation. What does it mean? Implantation normally should occur in the uterine wall. That is the normal site of implantation. And when there is zona pellucida throughout the fallopian tube passage, this over here, zona pellucida, prevents the implantation in the fallopian tube, because if the implantation occurs over here, then it will be ectopic implantation. There will be rupture of the fallopian tube, and even the bleeding, so much of bleeding and death may also occur to the female, obviously to the embryo and also to the female. So that is all prevented by the appearance of zona pellucida. When there is zona pellucida, there won't be any implantation. So now when it reaches the uterine wall, it knows that okay, I have reached my correct place for implantation. So zona pellucida starts to disintegrate and the fluid starts to enter. Then we call it as blastocyst, and then we around the sixth day we have what? Around the sixth day we have the beginning of implantation. I'm just saying beginning because this entire embryo has to go inside the wall. It is not just attached to by one stalk, entire has to go inside. So it is an implantation beginning, and that is your week one. Implantation beginning. Okay, so this is your week one, and here what is being shown to you is the stages of cell only. So morula is asked, blastocyst is asked, question come out of zona pellucida. You should try to make diagrams, can make the flowchart as well. So that was your week one. Okay. Now here's another image just to show you what is happening. So in the beginning, what we are seeing was a group of cells over here. We call it as blastomeres. Okay, we call it as blastomeres. Now see what is happening at the end of the first week only. There's a zoomed in image over here, that when the ZB disintegrates, then fluid enters. Now when the fluid enters, what happens is these cells are concentrated, or not concentrated, but they are pushed to one side. They are pushed to one side, this blue color cells, and they are known as, I'm writing just E over here, embryoblast. Clear? Rest, you have the fluid over here, FLUID, fluid over here. So these cells are pushed. But it's a ball, it's not a circle, it's a ball. Few cells, if I may change the color to say again to, let's say, black only, few cells are also pushed to the walls over here, to the outer walls. Okay. This I'm writing T over here. These are known as what? These are known as trophoblast or outer cell mass. So what is the difference? Difference over here is that this black color, or this say the green color trophoblast cells, which are the ones which are going to actually penetrate inside the uterine stroma, uterine epithelium for the implantation. And these blue colors are the ones which are actually going to give rise to the entire three germ layers. They are known as embryoblast. Because blast means something immature. So these are immature cells which are going to form the embryo. So we call it as embryoblast. Similarly, tropho means nutrition. So these trophoblasts are going to anchor inside the uterine wall. And what is the nutrition? They are going to form the future placenta. That is why they are known as a trophoblast. And here you have this blastocyst cavity. This is all is blastocyst that is occurring at around day 5. And this is obviously beginning of implantation. So we can call it as day 6. That is your first week. I hope the first week is clear. Now let's move to the second week. But before that, a couple of questions over here. In which of the following layers would a lowered rate of cell division be most likely to hinder implantation of blastocyst? Basically, they're asking you in this image, which cell that is having low rate of cell division, the implantation will be hampered. Okay, so there are seen the week 2, but trophoblast over here divides into cyto and syncytial trophoblast. And the answer is obviously the cytoplasm. Answer in this question will be our option C over here. Will be option C. But let me try to tell you over here what happens in week 2. Let me try to show you an image over. Look at this image. Just a second. Right over here. Now see what is happening over here. Now we are enter into week 2. So first of all, a bit of a couple of minutes theory for the week 2. Then you see what is actually happening in week 2. So what is happening now? Till now, you have seen that there is a group of cells outside. What was that known as? Trophoblast. E. And a group of cell which is going to form the embryo. So we call it as embryoblast. Correct? Okay. Now see what is happening. Week 2, in the beginning, I told you it is known as week of 2s. So everything will be divided into 2 and 2 layers. So first the theory part. Now this embryoblast, E for embryoblast, will divide into a layer known as epiblast. Epi means sitting above, and another layer of cells known as hypoblast. Hypo means sitting below. Epiblast and hypoblast. Okay. In this image, what do you see? This blue color is the epiblast. This blue color over here is the epiblast, and this small greenish color over here is the hypoblast. Clear? Then this TR trophoblast also divides into cytotrophoblast, okay, and syncytial trophoblast. In both of them, the cytotrophoblast is the one which is the dividing cell, and it divides into syncytial. Okay, in this image, if you try to see over here, then we can try to make out the cyto and syncytial trophoblast over here with the say the green color over here, not exactly labeled, but understand this. Light green color over here, this will be the CT cytotrophoblast. And this darker green over here will be the stage syncytial trophoblast. So two things. Now there are two cavities which form above the epiblast. Above the epiblast, there's a small cavity known as amniotic cavity. Now, if I try to highlight it a bit, that will be better. Look at the amniotic cavity, this yellow highlighted space over. This is the amniotic cavity. It is sitting over the epiblast, which was this blue color structure, epiblast blue color structure. And then similarly, there's one more cavity which is below the hypoblast, and that is this cavity known as yolk sac. So this cavity over here is yolk sac. So two cavities are also formed. Amniotic cavity and a yolk sac. Amniotic cavity is above the epiblast and yolk sac is below the hypoblast. I hope the point is clear. Okay, so this amniotic cavity, and you have this. For the hypoblast, you have the yolk sac. You have the yolk sac. This is all occurring in week 2. Now, this is actually now what you are seeing over here. You can see some maternal sinusoids. Let me just put an arrow over here so you can see. This is maternal sinusoid. What is sinusoid? The maternal blood from the uterine wall. So what happens, this green color, no, which you are seeing the cytotrophoblast and syncytial trophoblast, they are now actually invaded entirely into the uterine wall. Here, can you see this outer layer? This is from the outer layer where it actually entered. Understand this. This was the day 6 when it actually entered over here. Now, after 4 or 5 days, or after not 4 or 5, but after say 2-3 days only, it has now entered inside totally. And when it has entered inside totally, then the maternal blood vessels also do they rupture over there, and then the blood you can see is between the syncytial trophoblast over here. Okay, so you can see this green color is the trophoblast, cyto and syncytial. They are for the future placenta. While this inside, no, this epiblast and hypoblast over here, that is the developing embryo. Understand? And in between them, you are seeing two cavities also. We are seeing two cavities also. Plus, there is a space over here that is known as your chorionic cavity. There's also one more cavity known as chorionic cavity. So again, coming to your exam point of view, that is a bit of understanding which I'm telling you. You have to draw this diagram, guys, and in a bit well labeled manner. What you are also seeing over here is a term known as primary villi. Let me actually highlight. Let me do one thing. Highlight the important things that you actually need to, actually minimum things that you need to label. Okay. Chorionic cavity you can label, then you can label this epiblast, hypoblast, cytotropho, and syncytial trophoblast. These are things if you label, that will be good. This is happening in week 2 only. So in week 2, how many layers are there? 2 layers of embryoblast. epiblast and a hypoblast. So I repeat again, there are two layers, epiblast and hypoblast. So don't forget that. There are two layers, epiblast and hypoblast, star mark. Now, what is this primary villi? I hope we have, yes, over here. Now, villi. Villi means what? Villi means finger-like projections. The word villi means finger-like projections. Finger-like. What does it mean? See, now it is very simple, common sense only. And everything is common sense actually. When see, there's a uterine wall, thick uterine wall. Okay. And there's a small developing embryo. At the end of week one, it has just started to enter. But which part of this whole embryo will actually enter? What will enter? If you try to push a ball against a wall, do you think a ball will just rupture and it will perforate through the wall? How is it possible? The surface area around all the surface tension, how will that a ball can easily enter? It is not possible. Only a ball which has some thorns or some finger-like projection, they have some chances to actually perforate. And that finger-like projection is villi. I hope you get the point. A simple ball, you can't let it, I mean, it's not easy, obviously, to make it enter. So those finger-like projections are known as villi. So in the beginning, this is known as primary villi over here, as you can see. When there is a cyto and a syncytial, these two layers, they form primary villi. Villi means these things. Imagine a ball over here. On one side, you have finger-like projections. Simple as that. So it is primary villi, cyto plus syncytial trophoblast. Now, after a few days, from inside, there is a developing mesoderm also. This mesoderm also comes into play. The extra embryonic, it is nothing but extra embryonic mesoderm. And then we'll call it as a secondary villi. Secondary villi is primary villi plus mesoderm. Okay. Now I understand over here, this is the mother part over here, and that is the fetal part over here. Okay. Now, fetal part, that is developing fetus, is entering into the uterine wall. Clear enough? What cells have come from the fetal part? The trophoblast and the mesoderm. But how will the exchange take place? How will the blood or the food from the mother blood will reach the blood of the fetus? Are you getting a point? So for that, what happens is when this all villi are being formed from inside the fetus, the fetal capillaries will. And then in this, if we zoom this finger-like projections, in this finger-like projection, what will happen is that in between you have the small fetal capillaries. Okay, then we call it as tertiary villi. It is secondary villi plus you can see some villus capillaries, some capillaries of blood from the fetus side. So what is outside? Okay, this is the finger. Let me just try to show you. There's a finger, and what is outside? Outside over here, you have the maternal blood. You have what? You have the not the blood vessel. You have the blood over here between the villi. You will have the blood. But now, actually, what is the point that there are chances of, or not chances, but obviously there is diffusion of the food, waste material, everything, because now blood to blood are very close. Mother blood and the fetal blood vessel basically. And this is what we call it as, which type of placenta? It is known as hemochorionic placenta. Hemochorionic placenta. Chorion actually is nothing but cytotrophoblast plus syncytotrophoblast plus mesoderm, that is chorion. So hemo over here refers to the mother's blood. This area is maternal blood. And that was what we were seeing over here. If you see maternal sinusoid, no, this over here, maternal sinusoid, this is the blood which is lying outside. And in this villi, if you happen to imagine that there are villus capillaries from inside, this is the area where the diffusion will take place. Okay, so in humans, the type of placenta is hemochorionic placenta. That is also a placenta in itself a question. Types of villi are a question. In embryology, when there will be viva, you have the embryology models. In most of the colleges, they have this model also of showing different types of villi. Because we do remember that also. Okay, so this image also is showing us the same thing. This is the maternal side over here. There's a lot of maternal blood which has entered. This is a villi, and you can see the fetal artery, fetal vein, they all give branches over here, and this is the developing placenta over here. This is the maternal blood, this is the maternal blood, and here inside you have the capillaries over here, and this is where the diffusion will take place. Okay, so this is basically your week 2. Basically what? This is a week 2 over. So I just revise what happened in week 2. Week 1 ended in the beginning of the implantation, and week 2 implantation actually occurred inside. And the whole embryo is now inside the wall of the uterus. Understand this point? If suppose, just imagine, because that I have seen a student being confused. Suppose supposedly say this is the, say, the uterine wall, yeah, uterus, right? This all is the thick myometrium uterine wall. When we say implantation, no, when we say implantation, it is not over here. It is actually complete. It is inside. So basically, the developing fetus goes inside the wall of the uterus. Understand this? Okay, it is not anchored only at one side. It has to go inside, and then slowly as it will enlarge so much that finally it will cover the entire space, because the embryo and the cavities are enlarging. Enlarge. It will enclose the entire space. Okay, that is what the what happens in during the embryology part. So week 2 we have epiblast, hypoblast, and cytoplasm and pseudoblast, then amniotic cavity and a yolk sac. And also we have actually outside we have extra embryonic mesoderm also. You can see extra embryonic mesoderm, chorionic plate, chorion wire. So I hope you understood a bit of implantation. Now comes the last week, that is the week 3. And let me just over here, just a second. Fine. Just looking for some, so yeah, some empty page over here. So let me just give you an idea what happens in week 3. Then we'll see to it what happens in week 3. So now things are interesting. Just be with me for next few minutes to understand it. Week 3. What we are going to see mainly in week 3 is we are going to see mainly the part of the gastrulation. Okay, and then see more through the images. See, now week 2 has ended. We have one layer epiblast over here. Okay, and below we have this, imagine the hypoblast and epiblast over here. Okay, embryo has to come from here only. We need to see the gastrulation when the 3 germ layers are being formed. Clear? Now see what happens is that in this whole, which is it's actually known as a bilaminar disc. We are looking at a 2D picture. Understand? There are two plates, one over the other. The above plate is epiblast, the lower plate is the hypoblast. Is that clear? Now, what happens through this bilaminar disc? On one side, basically on the tail end side, a groove appears, and these cells, epiblast, they try to move down. And what they will do is they will push the hypoblast away. They will do what? They will push the hypoblast away. Okay. And from where they move down, that part is known as primitive streak. So actually, there is a groove from we can say the tail end of this bilaminar disc. There is a groove from which the above cells, the epiblast cells, they are going down. Okay, and they are pushing away the hypoblast. So there's that groove is known as primitive streak. Just understand this word primitive streak. Keep this word in mind, primitive streak. Now try to understand over here. There are 2 plates above epiblast. Now through this groove, epiblast will come down. They will displace the hypoblast. And imagine the 100 cells of epiblast, just for the convenience. Out of 100 cells, the 30 cells came down and they formed this first layer below. Now there is no hypoblast. The first layer that is formed below, that is known as endoderm. So which layer forms first is endoderm. Endoderm is the first layer to be formed. I get a point. Out of 100 cells, 30 cells, they formed endoderm. But now the cells, they don't stop. They keep on coming down, but the lower plate is formed. So they will form another plate above endoderm. The second layer that is formed is, you can understand yourself, above endoderm, there's mesoderm. So imagine 30 and 30 cells more went down, mesoderm. And finally, whatever cells were left in epiblast. So first they form the endoderm, then they form the mesoderm. Whatever cells were left in the epiblast, the last layer to be formed is ectoderm. This is how, through the primitive streak, the whole process of gastrulation occurs. In which week? Week 3. Main point is this. Understand this basic point. This is how the 3 germ layers are formed. 3 germ layers are formed. Let me show you some images over here. Yes, let's try to see this. These are the days which are written. 16 days. Week 1 is till 7th day. Week 2 is till 14th day. 16 days, we have entered into week 3. You can see the primitive streak over here. Okay, and at the head end of the stick, we also have a something known as primitive node. It is something like this. There's a primitive node and then there's a primitive streak over here. Now the cells of epiblast, they will start to come down from here, and the first layer they will form is the layer below this, that will be known as endoderm, then mesoderm, then remaining cells will be your ectoderm. So day 16 is this. After a couple of days, you can see the shape of the cell. The shape is changing. This side there is more width. Why? Because where there is primitive streak, no, from here the cells will first start to go down. So this side the width starts to decrease. Or obviously they'll come into the picture. There will be balanced symmetry later on, but in the beginning it is like this. Okay, let us see more. 19th day. Now there's a 19th day and 20th day. So there's primitive streak over here, but there's something massive happening at the head end of the embryo. Remember in week 3, we said two major events occur. One is gastrulation, which we have just witnessed. Second is what? Second is neurulation, formation of neural tube, neurulation. Neurulation. Understand this also through this image only. Now understand this. This is some, imagine the head end or the cranial end of the developing embryo. That is, imagine the tail end. The below is the tail end of the developing. Now epiblast cells are going down, fine. They're going down, 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 very good. Now whatever remaining cells are over here, what do they become? They become ectoderm. Yes or no? After they form endomeso, what is left above? Above is ectoderm. Fine. Now see what is going to happen through primitive node. Listen very carefully. That through this primitive node over here, the cells which are going down, they don't form a whole disc. But what they do is they start to form a rod of cells below the ectoderm. This is, try to understand, this blue rod which I'm trying to make over here is below the ectoderm. Just for understanding, I'm making like this. And this is known as what? That is known as a notochord. N-O-T-O, notochord, notochord. It is where below the ectoderm. What will it do is, it does now see, there's a plate ectoderm. Okay. Now from this primitive node, there is a rod of cell below. Suppose I put my finger like this, that is notochord. So this is notochord, above is ectoderm. Clear? Now what is notochord? It is going to induce some changes over here. Not in the entire ectoderm, but wherever the notochord touches the ectoderm, that changes will be happening at the place where the notochord is touching the ectoderm. And then what happens is this part of the ectoderm, it becomes a neuroectoderm. What does it become? Neuro. So it is a part of ectoderm only, but it is slightly different from the ectoderm, and that is known as what? A neuroectoderm. So let me write over here that this part becomes neuroectoderm, and the remaining ectoderm becomes a surface ectoderm. It becomes surface ectoderm. Now this neuroectoderm is going to do what? It is going to fold, and that folding of the neuroectoderm is known as neurulation. Understand this. Now, I give you two statements over here. Listen very carefully. Right now, you are witnessing the neuroectoderm. Now, what is responsible for formation of neural plate? You can call it as neuroectoderm. You can call it as, you can say neurulation, neural fold, neural group. Say, give any name. What is the main thing responsible for it? The main thing responsible for it was this notochord. So notochord is the main factor for the whole CNS development. Yes or no? Similarly, if someone asks you what is the defining structure for the gastrulation to occur, you will say, sir, it is primitive streak. If there was no primitive streak, no epiblast will go down. It is only through primitive streak. So primitive streak, as it is important for gastrulation, similarly, notochord is important for neurulation. Understand this basic concept over here. I hope the point is clear. Let me show you some images over here. Look at the images. This is which day? As below you can see, let me use a highlighter over here. This is day 19th. So till day 21, we have the third week. Okay, 7 into 3 is 21. So you can see the neural plate has started. That means notochord has done its job. Neural plate has. Where's notochord? Below. So below, just imagine this is a primitive node over here. So below over here, somewhere over here, we have the notochord that is doing its job. It is converting this part of the ectoderm into neuroectoderm, and this remaining part will be SE. SE is what? Surface ectoderm, and this is NE, neuroectoderm. You got the point, right? Then there's neural groove and the neural folding. This all process known as neurulation. Day 20 is still within 3 weeks. So we say neurulation occurs in week 3, right? See the more images. Now 22 days. Now we are enter into which week? We are now enter into 4th week. But understand the neural folding has begun in 3rd week, continue till 4th weeks. Why? Because now here a couple of points can be asked. What is that? See, when there's folding which is occurring, no, so what ultimately happens is that the yes, over here you can see in day 22 what is happening. This is a neuropore, which is more on the anterior side, so we call it as anterior neuropore. And there's an opening behind known as posterior neuropore. What is that known as? Posterior neuropore. If I ask you where is all this happening, on the ectoderm side or on the endoderm side? You say obviously ectoderm side, this is neural fold is ectoderm only, correct? Now, ectoderm side, if you recall gastrulation, it was epiblast side or hypoblast side? It was, sir, above say epiblast side. Very good. So this all is occurring at the side of epiblast. If we go with the 2nd week, now what was the cavity above the epiblast? Sir, cavity above epiblast of very good. It was amniotic cavity. Yes or no? Having the amniotic fluid. So when this whole neural tube is opened, then there are pores on the anterior posterior side. The first fluid to enter through the tube is amniotic fluid. So in the beginning, the amniotic fluid travels inside the neural tube till the pores are closed. Till the pores are closed. Pores normally close around the 4th week. Okay. Day 24, we have around the anterior neuropore closes, and day 27, 28 is around when the posterior neuropore closes. And if they don't close, that is also actually a question. Suppose the anterior neuropore doesn't close. Then you have over here a problem like anencephaly when the brain is totally opened up. And obviously, this sort of stillbirth, that embryo doesn't survive. And when the posterior neuropore doesn't close, it is you have a range of disorders known as spina bifida. It is a range of disorders. Spina bifida, you have occulta, you have cystica, all of that. When the lower back, you have some swelling in a newborn child, in the lower back, if you have a swelling, that could be spina bifida. This happens when the neuropores they don't close, and they normally close around the 4th week and or 4th week. Some anti-neuropore closes around day 24, if I'm not wrong the exact date. As far as I remember, it is day 24. And the posterior neuropore closes around day 27 or maybe day 20. Okay, but it happens like this. And here you can see, yes, on the day 25th, on day 20th, if you see, pores have closed already. Right, and then there's folding of the embryo and the somite development, all that. So all that development occurs after that. Okay, I hope this point is clear. Now let us see if there was some question. Yes, let's see we do an MCQ. So here the MCQ asks indicator of the start of gastrulation is the formation of. See, I already discussed this. Neural groove, neural pit, primitive streak, or formation of notochord. What was the answer? Answer is primitive streak. If they change the question, indicator of beginning of neurulation is the formation of. For neurulation, it will be notochord. Okay. Yeah, here is an image. This is actually a TS over here. Try to look at this image and try to understand this. This is a TS like this. So what we will witness over here is, first of all, let me try to make on the side. We have this ectoderm above. We have the endoderm below. In between, we have the mesoderm. Now see what happens is ectoderm is the one that is going to form the skin and all. Endoderm is the one that is going to form the lining of the gut epithelium, lining of the lungs. In between all of this, all the bone, the muscles, the blood vessels, lymphatics, lot of things are found by mesoderm. Therefore, mesoderm is very diverse. So mesoderm rapidly divides into 3 areas that we'll discuss. I'll show in the image, but we'll come to it a bit in a while. But understand, from the ectoderm came what? It came the, what is this? Neural tube. Yes or no? This is a new neural tube. It came from ectoderm only, no? And what was responsible for the neural tube? What was that solid cord of cell below? Notochord. So imagine this is to be NC, notochord. And that I'm writing over here, anti-neural tube. Agreed? This is the endoderm, and that is the surface ectoderm. Agreed? In between, you have the mesoderm. Mesoderm is divided over here into a lateral plate mesoderm, an intermediate, and a paraxial mesoderm. That is. So on this side also paraxial mesoderm, intermediate and lateral plate mesoderm. It's a TS. We have cut like this. Now, see, this is an electron microscopic image over here. Focus, if I try to highlight few things over here. Right. So look at the neural tube. Yes or no? On the just below the neural tube, look at the notochord. Understand the importance of notochord to neural tube or neurulation. On the side, the somite is what? It is paraxial mesoderm. On the side of somite, you have the intermediate mesoderm that which I wrote over here, and the side of it, you have the lateral plate. So mesoderm rapidly divides, but it has to form so many things. And below you have this layer over that will be probably a part of the endoderm over here. And that above is the ectoderm. This is all is surface ectoderm above. This is all is giving rise to skin, hair, nails, and other stuff. This is your actually third week. This is third week. This is how our general embryology takes place. Okay, so you understood. Basically, we focus more on the concepts and diagrams, flowcharts, they are a must. Always do remember it. This general embryology for some students it might find you a bit boring. I'll sir, why to learn all of this? So much to learn and all. Remember, it is very important. Not just for passing the exam. Obviously, that is important, no doubt. Currently, you should focus on that only. But if you look at the larger picture, then all the congenital anomalies, a lot of diseases, a lot of pediatric syndromes are related to changes over here. Because understand, no, a slight change in the beginning 3 weeks, and then the whole system will collapse. You get my point? It's slight change to the neural tube. Well, the brain is opened up, child gets stillbirth. And therefore, for this, if you don't know that, let me tell you, because the neuropores, when they don't close, I told you a couple of diseases, so therefore folic acid is given to the expecting females, expecting mothers. Folic acid is given. When the couple is planning a baby through the female, the folic acid is given. It is seen that it helps in closure of the neuropores. Understand? So there are a lot of diseases over here. So understand this. It might look a bit boring. You might not correlate it what you see in a normal public. But if you go to the pediatrics ward, if you go to obs and gynae pediatric ward, look there, then you will understand how much important they are. So I'm just giving you a context of why this is important to generate interest in you guys for this particular topics like embryology. Okay, I hope that's fine. And tomorrow we'll do some systemic embryology and maybe some questions from here. So remember, embryology diagrams, flowcharts, be specific, right? Also, do remember over here that will be a bit of homework for you. What are the derivatives of all these three germ layers? That you can do a homework, or tomorrow I'll possibly show you some images also for that. That mainly what I'm asking you, ectoderm give rise to which adult cells, mesoderm gives rise to which adult cells, and endoderm gives rise to which adult cells. What are the derivatives of all this? This also you must know. Okay, again, that applied part is there. Okay, so that's all, guys. I hope you enjoyed and hope to meet you again very soon tomorrow, probably looking at other aspects of embryology. So that's all from my side. And thank you. Bye bye. Good night and do your revision.